Welcome to Week 3 of Introduction to GIS. This week we're going to focus on spatial data, the types of spatial data you will work with in a GIS, how you describe spatial data, and things you should think about when mapping your data. In the most broad sense, spatial data is any data that can be mapped. It is any information about the locations and shapes of geographic features and the relationships between them. As we learned last week, data in a GIS represents a simplified view of physical entities, including their spatial location, extents, and information on their non-spatial properties or attributes. Each object is represented by a spatial feature in the GIS. Because of technology limitations, we typically represent abstractions of reality. They are imperfect because we can only record a subset of the characteristics of any one object. No abstraction is universally better than any other, and the goal of the GIS user is to define objects that support the intended use while maintaining the desired level of detail and accuracy. Coordinates are used to define the spatial location and extent of geographic objects in either 2- or 3-dimensional space. Going back to high school geometry class, location can be specified with the Cartesian coordinate system, coordinate pairs of x and y, or coordinate triplets of x, y, and z, or in a spherical coordinate system like latitude and longitude. Discrete features include points, lines, and polygons. A point might be a house address, a line might be a stream or a road, and a polygon might be a land parcel or building footprint. These are also called vector data types. Continuous geographic features are defined as phenomena that exist continuously in the landscape. Examples of continuous geographic features include elevation, temperature, relative humidity, gravity, wind, atmospheric pressure, and so on. This is considered the raster data type. Features can also be summarized by a geographic area. Many discrete measurements within a specific polygon or specific area are summarized into a single value. Examples include population, socioeconomic characteristics, and other demographic information. For example, we might be interested in population density per square mile by census tract in South Carolina, as this example shows. The features are summarized by geographic areas or by census tract. Instead of having a point represent a specific population or specific purpose, all population from the geographic area is summarized and displayed on the map. The Census Bureau compiles population data by census tract, block, county, and state. This helps to analyze the data at a larger scale. Also, when there are privacy concerns, it's very important that a single individual piece of information isn't exposed. Vector and raster are two very different ways of representing spatial data. However, the distinction between vector and raster data types is not unique to GIS. Graphic designers also classify data as raster or vector. The next videos in this module will help you differentiate between these two spatial data structures.